Resistors are a common and important electronic component. They are often used to control current in a circuit. View our video Ohm's Law for an explanation of the relationship between the three basic electrical properties: resistance, current, and voltage. The unit of resistance is the ohm. The symbol for ohms is the Greek capital letter omega. Resistors come in a variety of physical sizes. Large resistors typically have a higher wattage rating than small resistors. The value of a resistor is sometimes printed directly on the resistor. Most small resistors use a series of color bands to indicate their value. In this system, colors represent numbers. Here is the key. Black is 0, brown is 1, and so on. Here's how to calculate the value of a resistor using the colored bands. This resistor's color code is yellow, violet, red, gold. The gold band isn't part of the value code. It tells us the tolerance of the resistor. Gold band resistors are accurate to within 5% of their stated value. The colored bands yellow, violet, red represent the value of this resistor. Here's how you interpret this code. Checking the color key, we see that the first two colors, yellow and violet, represent the numbers 4 and 7. Record those two values. The third color band, in this case red, is called the multiplier. It tells us how many zeros we add to the first two numbers. Red represents 2. We need 2 zeros. The value of this resistor is 4,700 ohms. Here's another one. This resistor has the color bands brown, green, red, gold. Checking the color key, we see that brown represents the number 1, green is 5, and red is 2. Again, the gold band isn't used to determine value. The first two numbers are 1 and 5. The multiplier is 2. This tells us to add 2 zeros to the first two numbers, giving a result of 1,500 ohms. Following are images of 3 different resistors. Pause the video on each image and determine the resistance. Resistors reduce current flow in a circuit. This image shows the effect of a resistor on the brightness of an LED. The brightest LED is connected to a 2,200 ohm resistor. Next is 3,200 ohms, then 33,000 ohms, and finally 100,000 ohms. Some resistors use additional color bands to indicate more precision. You can use a digital multimeter to directly measure the value of a resistor. Set the meter to measure resistance. Depending on your meter, you may have to select a range. For this example, I have chosen a range of 0 to 200 ohms. Once set, then touch the probes to each end of the resistor. The measured value is often slightly different from the value indicated by the color code. According to these color bands, brown, red, brown, this is a 120 ohm resistor. The meter shows a value of 119.7. This value is within the 5% tolerance range for this resistor. This is a 1500 ohm resistor. The meter is indicating 1.54K, or 1540 ohms, again within the tolerance range. This is a 10 watt 220 ohm resistor. Its value is also within the 5% range marked on the resistor. The compound used to make small wattage resistors is similar to the material that pencil lead is made from, graphite. You can create a variable resistor with a heavy pencil line on paper. Touching the meter to each end of this line shows a resistance of over 150,000 ohms. Sliding the probes closer together, we see the resistance dropping into the 20,000 ohm range. Using this pencil lead resistor in a circuit with a battery and LED, we can see the effect. Sliding the contacts controls the brightness of the LED. If you try this, be sure to use a suitable current and low voltage source for the LED. Excessive current could damage the LED. You could be injured. This is a variable resistor. The pencil line models what is happening inside this device. Sliding variable resistors like this are used on audio-video mixer boards to control input and output levels. Variable resistors are commonly called potentiometers. This is another type of potentiometer. The control rotates. View our video Ohm's Law for an explanation of the relationship between the three basic electrical properties: resistance, current, and voltage. We have more information about electronic components and circuit construction at our website, hylaroad.com. Follow the project's link.